Okay, in this video, we're going to take a look at what are known as one-sided confidence intervals, which is something that we're going to see when we get into hypothesis testing in another video or so. So the confidence intervals we've been constructing so far in this section have been two-sided confidence intervals. And we have the total area outside of our interval is alpha. So for instance, for a 95% confidence interval, we have a 95% between these two extremes and then a 5% to share between these two areas in green. So if we have 95% in between, that means we'd have 5% outside, and each one of them would get half of that 5%, which is 2.5%. And for a 95% confidence interval, our critical z-scores here, or critical values here, are going to be negative 1.96 and positive 1.96. So when we took a look at total area outside of a normal distribution or in between, and finding those z-scores, that's how we get the negative 1.96 and positive 1.96 if we have a 95% confidence interval. We've seen for higher confidence intervals, it pushes these z-scores out even further. But in terms of this confidence interval, this is a two-sided confidence interval because we do have part that is to the left of this extreme, and we have a part that's to the right of this extreme. And again, notice the endpoints of our interval are plus or minus z sub alpha over 2. So if we use a 95% confidence interval, we have 2.5% to the left of this extreme, this lower z-score of negative 1.96, and we have 2.5% above this extreme, this z-score of positive 1.96. And if we add them all up, 2.5, 95, and 2.5 adds up to 100%. However, for a one-sided interval, in order to have the same area outside of our interval, our critical value is going to need to change. So for this one, if we have this 5% in green, and this time our confidence intervals only going to the right here, 95% beyond this value, this has a z-score of negative 1.645. And again, we can calculate what the z-score is based on the area to the left of it using the technology and methods that we looked at with standard normal distribution. Well, here we have this z-score of negative 1.645 as the lower bound on this one-sided confidence interval that goes to the right, this one-sided 95% confidence interval. So notice when the confidence interval is no longer two-sided, we went from negative 1.96 now to negative 1.645. Likewise, if it's going to the right, if this area here is to the right where it's 5%, then 95% of the data is going to be to the left of that, and that has a z-score of positive 1.645. So this positive 1.645 is an upper bound for this 95% one-way or one-sided confidence interval. And if you notice the negative 1.645 and positive 1.645, you might remember those values from calculating 90% confidence intervals, or 90% of our values within the mean of a normal distribution, that now we can get those same numbers, the negative 1.645 or the positive 1.645, by constructing not a 95%, but a 90%. So notice these ones now, they were at 2.5% each when this middle one was 95, but now we've doubled that amount. 2.5% when we double it is 5%, and we can get those exact same critical value z-scores by, instead of a 95% confidence interval, take a 90% confidence interval. So whatever that value of alpha is for a one-way confidence interval, we can get either of these values by doubling that value of alpha. So from 5% originally to now 10% total area left and right of these two critical values. So for left or right tailed hypothesis testing, which we're going to get into in a couple videos, some statistical software is going to report the one-sided interval. I know Minitab, if you use that one, that uses a lower bound and upper bound. That's a one-sided interval. Others are going to report the usual two-sided interval with that adjusted value of alpha. So others would give you a, if you look for a 95% confidence interval, one-way confidence interval, it would give you a value of 1.645 as an upper bound, or it might give you a value of negative 1.645 as a lower bound. But then others will give you what these values are with a 90% confidence interval as opposed to a 95%. And that is, again, we'll talk about left and right-tailed hypothesis testing in a little bit, but just so you're aware, when you see some of the outputs from the statistical software, I just wanted you to kind of get an idea of where those were coming from. For the ones that do give you a normal confidence interval for a left or right-tailed hypothesis test, the two-tailed ones are the ones that we're used to seeing. So, and when we'll see examples of this in the hypothesis testing sections as well. But the two-tailed hypothesis test is confidence intervals just like normal, so z sub alpha over 2. But with a one-tailed test, like when we went from 2.5% on the extreme values to 5%, we had to double what this value was. And when we double alpha over 2, we get alpha. So if we had z sub 0.025 for 5% divided by 2, this one would be z sub 0.05 or z sub 5% for a one-tailed test. So in the programs that I've written for that I'm going to be using, we'll see one-tailed confidence intervals for ones that are left or right-tailed hypothesis tests. But we'll get into that in a little bit. But I just wanted you to be aware of what you might see in various statistical software as you progress through hypothesis testing, and perhaps even using a confidence interval approach rather than the traditional test statistic critical value or the p-value approach, which we'll learn about in another video. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.